Hey there! In this video, we are going to solve a differential equation using Laplace transforms. I have the equation y prime minus y equals 2 cosine 5t, and the initial condition y of 0 equals 0. And I want to use a Laplace transform to solve this. So the first step is always going to be to apply the Laplace transform to every part of the equation. So that means I'm going to take the Laplace of y prime minus the Laplace of y equals the Laplace of cosine of 5t. And I'm just going to take that constant 2 that's multiplying by cosine of 5t and put it in front of the Laplace because we're not going to need it. It's not going to help us to evaluate that Laplace. Okay, so on the left side, I'm taking the Laplace of a derivative. And so I'm using a formula. This is going to give me s times y of s, which is another notation for the Laplace of y, minus y of 0. So that's what I get for the Laplace of y prime. Minus, and then the Laplace of y, well, that's the same thing as y of s. So there's my left side of the equation. On the right, cosine of 5t, that's going to be s over s squared plus 5 squared, or 25. And then adding the 2 out front, I get 2s over 5 squared plus 25. Okay, so I've taken the Laplace. The next step is to use the initial condition since I have a y of 0 showing up on the left side. And that was just 0, so this term just zeroes out, which means I have s y of s minus y of s on the left side. And so I will factor the y of s out of those two terms because I want to solve for y of s. So I get y of s times s minus 1 equals 2s over s squared plus 25. Okay, so to solve for y of s from here, I need to divide by s minus 1. So I get y of s equals 2s over s squared plus 25 times s minus 1. Okay, so to finish off this problem, I want to take the Laplace inverse of both sides of this equation. But I'm going to do some work to the right side of this equation so that it's ready to easily apply a Laplace inverse. Right now I have 2 factors in the denominator, and so I want to use partial fraction decomposition to break down this fraction as much as I possibly can to make it easier to find the Laplace inverse using our table. Okay, so off to the side here, we're going to take our 2s over s squared plus 25 times s minus 1, and we'll figure out how this would break down. So I need a fraction for the s squared plus 25 and another fraction for the s minus 1. And since the s squared plus 25 is an irreducible quadratic, there is the possibility that there's a binomial in the numerator. So as plus b is going to be my proposed numerator for that one. And the other one, s minus 1, that is just going to be a constant. Okay, so there's my setup. I will multiply by the common denominator of s squared plus 25 times s minus 1 across this whole equation to wipe out all of the fractions. So I get 2s on the left, and then as plus b is going to be multiplied by s minus 1 plus c times s squared plus 25. Now, sometimes we will just pick a value for s and start plugging it in. It doesn't work so great here because of that as plus b multiplying by a binomial. So I am going to go back to the traditional method of setting up a system of equations from these coefficients. So the next step will be to distribute everything, get rid of all the parentheses on the right side. So 2s is going to equal as squared minus as plus bs minus b plus cs squared plus 25c. Okay, so collecting like terms, I have 2s squared terms, so a plus c has to equal 0 since there is not an s squared term on the left. I just have, let's see here, one BS term. So B is going to equal 2. Oh, no, there's the other one. I knew I was missing something. There's an AS term as well. Okay, so negative A plus B equals 2. And then I have the constant terms, negative B plus 25C, and those have to add up to 0. Okay, so there's my system of equations. It's a tricky one because no two equations have the same two unknowns in them. So I'm actually going to take these first two, add them together to cancel out the A, and then I'll have two equations with B and C in them that I can solve. Okay, so if I add those together, A plus C equals 0 and negative A plus B equals 2, I end up with B plus C equals 2. Okay, and then if I add that to the third equation, I'll be able to cancel out the B's. So B plus C equals 2 minus B plus 25C equals 0. And so that's going to give me a 26C equals 2, which means C equals 1 over 13. And I've got my first solution. Okay, so now I can back solve that into the others. B plus 1/13 has to equal 2. So that means that B is going to equal 25 over 13. Use a calculator for these. And then A plus C has to equal 0, which means that A equals negative 1/13. Okay, so all that work I did off to the side now, I can use over here on the left with my differential equation I started out with. So y of s is going to be equal to, let's see, a few different fractions here. Let's see, I have a 25 over 13 and a negative 1/13 for the first one. So negative 1/13s plus 25 over 13 over s squared plus 25 plus 1/13 over s minus 1. Okay, so when I'm going to apply the Laplace inverse here, but I'm also going to clean it up a little bit. I'm going to pull all the 1/13ths out of these fractions, just to make it a little easier to deal with. So I take the Laplace inverse of y of s on the left, and then let's see, I'll factor out a 1/13th Laplace inverse of s plus 25 over s squared plus 25. And let me not forget that negative there. Plus 1/13th Laplace inverse of 1 over s minus 1. Okay, so it's looking better. The last one is going to give me a power of e, I know from the table. This first one, though, I need to break this one down a little bit further. And so I'm going to have y of t on the left, because the Laplace inverse of y of s is y of t. And then I'm going to have a 1/13th Laplace inverse of negative s over s squared plus 25. Okay, and so that's just taking the first term in the numerator over the denominator. And then I'll have a second Laplace inverse, still with the 1/13th out front, for the 25 over s squared plus 25. And now these are all broken down and ready for me to evaluate. Actually, I'm gonna go ahead and pull the negative out of this first one as well and put it with the 1/13th, just to make it match the table. So it's good to have a table of Laplace inverse and Laplace transforms with you when you're solving these problems, so you can just look these up instead of trying to memorize them. But if I start evaluating this, let's see, I've got a negative 1/13. And when it's s over s squared plus 25, that's cosine. And it's going to be cosine of whatever's being squared in the denominator. So 5 squared is 25. So this is cosine 5t. Okay, and then the next one, plus 1/13. When it's a constant in the numerator, that is sine. So this will be sine of 5t. And then the last one, plus 1/13. And this is a power of e, where the a in the exponent is 1. So this is going to be e to the t times the 1/13. And there is my solution to this initial value differential equation problem.